So a couple of examples. Number one, I just wanted to point out that in the textbook, I don't believe it's standard in exams and what we do under the task system. But what they do is they use little p of x to describe PR they use, PR of x equals x. So that's all that little p of x means. It means PR of x equal to little x. Okay, keeping that in mind then, does this meet the conditions to be a discrete probability distribution? Well, for that, we need discrete values, which we do, and that these probabilities have to add up to 1, which they do. So this does meet the conditions for a discrete probability distribution. If it didn't, it means there are values that aren't here somewhere, and therefore it's not discrete or the probability is not complete. This is the bit I really wanted to focus on, though. Find the probability of x less than or equal to 2, big X there. So big X less than or equal to 2 simply means match the discrete outcomes that fit that description. X less than or equal to 2 would be this one, and this one. You're given these probabilities, so you are literally adding up those 3 probabilities to get 0.6 as the probability. In other words, the probability of there being a 0, 1, or 2 as the outcome is 60%, 0.6. That's all that means. Does that make sense? If it said greater than, oh, hang on, let's have a look at example 14 in case it does. Yeah, we won't do the conditional example 13 actually. This one here is find the probability distribution of x and show that all probabilities sum up to 1. So you can see that they've listed all the probabilities. We've done this already. So there are 0, 1, 2, or 3 heads that could be shown. There's the probability distribution there. And you can show that it is all there by adding them all together to find that the probability is equal to 1. The second thing is it says find the probability that 1 or more heads show. Well, you need to rephrase that into what does that mean as a statement with a big X? Well, 1 or more heads would be 1 or 2 or 3 heads, right? So it would be the probability that X is greater than or equal to 1. That's why that's written there like that. X greater than or equal to 1. And then you can just say, well, that's that one, and that one, add them together, and you get 7/8. Find the probability that more than one head shows. Well, that would be 2 or 3. So more than 1 would be the same as greater than or equal to 2, which is adding that and that together, which gives you a half. And that's basically it for how to do the arithmetic on a probability distribution table. I also need to show you how conditional probability works, but not in this lesson. Okay, I appreciate there's not much time left in the lesson, but I'm going to put some work up for you to have a crack at, and you'll need to complete some more for homework.